we started right here. Okay. These were all your parents, all the descriptions, all the movements, everything we were doing with our functions. Not sure why I got the yellow line in there. Okay, but anyway, then everything down. We went on and did some others. All of these are important parents that we had done. And, your class did not get into the sine or cosine. Just a couple things I would say to you. We're going to see this all later. Both of these have a center of the x-axis. And you know a sine curve because it starts on 0, 0, goes up to 1, comes back down to y equals 0, back down to a -1, and then it starts over again. That's a sine curve. That's the parent. Cosine curve, I could probably do better on that blue line. Let me see. It center is the x-axis as well, but it starts at 0, 1. That's what I say start. You know, it actually starts from -infinity, but we can identify it easily by saying, oh, okay, this starts at the top, comes down to the y is 0, then goes down to the -1, then it goes back up to the 0, back up to the 1. So that's your typical shape of the parent cosine, whereas this was the typical shape of your parent sine. Okay? Just, it can be confusing. Video. And then we started talking about moving things, changing our parents. So there's a lot in this set of notes that we talked about. We even talked about the compression, how it's related. I see this mark right here. This goes to here. This goes up here because horizontal stretch is the same as a vertical compression. You can always pause. Then more notes. Some of those were circled, so that means they were your homework, and I may have still done them. So just to, again, I see some that are circled. I do see one that I didn't do, so therefore you were supposed to do this one. Hopefully you did it. I'll be looking for it for like a minute. Then we did some more of the homework problems. I see a lot circled, but we've talked about them. So there's no reason this page isn't complete. And then I see 2 that are beautifully done. I love these. I love those a lot. And I left 2 for you to finish. I'll be looking for them. I was telling you that the log of x looks the same as the natural log of x. Notes. And then we had some more graphing functions. It's a lot more practice. We treated this as more practice. The blanks is some of the LN. I did all of those. And I did not do, I did the graphs, but I visually did the graphs. I didn't even really work that hard on them. But you're still having to do that. Okay? And then from there, still filling. I don't think for those, I find any more of those slides. Called it quits, show you. But back, just all the way do those. This top, do that homework. Didn't sign that quiz. Could sign that quiz to the beginning. Good quiz. Did all those notes on operations with functions. Those are all done, except I don't see this one done. So it wouldn't be bad if you did it. No, actually you should do it. If you got nothing else to do. Okay, class, this is for the class period that I needed to finish the notes. Just to remind you, if I go all the way, Then I said skip this section, and I did a good portion that would get you going on these composite. Was it composite? No. These were adding and subtracting. I'll do one more of 5 just for fun. I will add G and F. That would be square root of x minus 2 added to the square root of x plus 6. The reason I did this problem, because you can't do nothing else with it. That's it. You cannot combine radicals when you're adding. But multiplying down here is another story. You can take the square root of x minus 2, and you can multiply it by the square root of x plus 6. And all that means is this, guys. Maybe this is a blast from the past. You can combine the radicals by putting both inside the same radical. But that's it. I mean, there's really nothing else you could do. Yeah, you could FOIL that out and make it a trinomial, but it's not needed. And division, may as well. F divided by G is square root of x plus 6 divided by the square root of x minus 2. The only thing you could do with this is to do one radical and put them in together. That is a legal move. That was an x minus 2. Nothing else you could do. Can't cancel nothing out. Okay? So with that being said, that would be enough to understand plussing and minusing and multiplying. We're going to go to composite functions. So you're going to, as always, put your first name. Please print your first name. Please print your last name. Today's date is 11/9. And we're just going to do compositions. And whatever period you're in, whether it's 1A, 2A, 3A, whatever, please put it. Composition of functions. Another method to combine functions is called composition. If we have two functions, f and g, both with respect to x, a composite function could be written as, see the little circle in there? Let me zoom in. We could say this, f of g of x. F of g of x. So I'm going to write it like this, though. F of g of x can be looked at one function eating the other function. F is on the outside, so the inside becomes g of x. All of g gets eaten in place of, if you have an f of x, all of g gets placed into the x. You can also, I'll just add it, you could have g of f. That doesn't look right because of also has the OF. Let me space it better. G of f of x really is the g function so hungry that it's going to eat the f function. And as always, she's always nice to talk about what the new domain's going to be. You can read that yourself. I'm not going to hold you to accountable for that. So let's do some examples. We've got f is x plus 7, g is x squared minus 4. I write this as f of g of x. That way I know all of g will be substituted right inside the f wherever there's a zero, wherever there's an x there. So if f is x plus 7, in place of x, I write x squared minus x. I got to erase what I have there so I can see it. Yeah, oh no, x squared minus 4. X squared minus 4 in place of this x. And don't forget, there's still this plus 7 here. Plus 7. So when the f ate the g, you have x plus 3. Now what we're going to do over here, I'm pretty sure we're going to take the g, and the g is so hungry, the g is going to eat the f of x. So what was g? Let me look over here again. G was x squared minus 4. G is x squared minus 4. So pay attention to this x right here. It has to get the f right there. So what was, what's going to be squared? What's going to be squared? All of f. And remind ourselves, f is x plus 7. X plus 7. So I say x plus 7 is being squared. And then what was after x? There was a minus 4 here. X squared minus 4. That means all of f being squared minus 4. And I hope you know how to do x plus 7 times x plus 7. The shortcut, instead of using FOIL, which is exactly the same answer, is x times x is x squared. Positive 7 times positive 7 is a positive 49. Now we know that when we do this with FOIL, that was the first and that was the last. All we're missing is the outsides for the O and the insides for the I. But if you look very closely, it's x times 7, 7 times x. So what we have is 7 times x doubled. So that would be a plus of 14x. Don't forget, though, I still had this minus 4. That was part of the g function. Equals to x squared plus the 14. Let me back that up. Pen run on top of itself. 14x. And then, of course, 49 minus 4 should be 45. So composite functions is nothing more than a function eating another function. This is not new. It should have been taught in your Algebra 2 class. All right, f of g implies g is getting eaten by the f. So I look over there, and that means all of this gets in place of the x right here. So we write 3 minus, and what is all of x? All of x is going to be g, which is x over x plus 1. Now, in all reality, that is true. It's a very good 3 minus this rational function. But we can do better because we are pre-cal students. We should be able to simplify. So we're going to treat this 3 as a fraction, 3 over 1. And we know the answer is going to become I'm going going to do the butterfly, but I know that the bottom 2 will become the denominator. 1 times x plus 1, x plus 1. With the numerator, bottom right, multiply it crisscross, so that gives you a 3 times the x plus 1. And then when you look carefully, this is a subtract. So I go subtract, and then I start from the bottom left, multiply straight up. 1 times x is x. The bottom is x plus 1 because that's what 1 times x plus 1 was. Of course, we should simplify this a bit. Equals to. Let me just continue over here. I don't have to do the other one there. Distribute 3x plus 3 minus the x all over x plus 1. Okay, with that 3x's minus the x, we always combine like terms, equals to 2x's plus 3 all over x plus 1. Can't see the yellow very well. X plus 1. 2x's plus a 3 is over x plus 1. Doesn't matter. You get the idea here. If you were doing b, we would take all of g and substitute f of x for the g function. Because what I like to say is the outside function is eating the inside function. We can do another one. Let's drop down to example 3. If you look at what is portrayed here, you've got a cubic and we've got a linear. So when I do A, it's going to look like all of F eating the G. All of F eating the G. So all of G goes into that X right there. So the 9 minus the 2, something being cubed. What's being cubed? What's being cubed? All of the G, because G is on the inside. G is 4x plus 1. Now, I don't really want to finish that one because it's one thing to square a binomial, 4x plus 1 squared. That's pretty easy. 4x plus 1 to the second power using the shortcut, 16x squared plus a 1. Then we take the insides and we say, take 4x times 1 and double it, so plus 8x. That's fine. But when it's a cubic, then you'd have to take all of that answer times the 4x plus 1. Well, I got things to do today. So I don't really want to simplify this. You can if you want. I'm just going to do this. I'm going to say, and I probably wouldn't expect you to do it either. Not really. 9 minus 2 times 4x plus 1 times 4x plus 1 times 4x plus 1. You know what? If somebody finishes that and is the first person to send it to me on Remind, I'll give you extra credit, but I don't want to do it. Okay. How would it look if I do B? That means G is very hungry, eating f of x. Okay. So I go look over at G and say, oh, G was that line. So I'm going to remove my scribble on this. So if I'm doing G of F, G, this X right here, has to be all of F. That shouldn't be too bad. So now that's 4 times 9 minus 2x cubed. And don't forget the plus 1. So equals to 4 times, wasn't it, I already forgot it. 4 times 9 minus 2x. 9 minus 2x, that's being cubed. That's not cubic. 9 minus 2x cubed. Forgot my cubed. There it is. There's my 4x. Was there anything else? I think there was. I think there was a plus 1. Don't lose it. All of this is what f was. This, unchanged color, is f. This was f in place of the x of g of x. This replaced this. Now, this is easy. I can do this. I can distribute my 4 only to those two. Final answer, 36 minus 8 x cubed plus a 1. Okay, the 36 can add the 1, so I still have a negative 8x cubed plus the 37. That is the gist of composite. Let me see what's... So, finish your notes, turn it all in before you leave to the substitute. Thank you. There's just more. There's just more of them. Okay? I don't need to go further. That's enough. It'd be fun to do more, but time is money. And money is time.